Hello. Hope this microphone is on. Let's answer some questions about probability. So I didn't copy all of them down, but you know what they look like. So first one, that was number 3. It said, gave you a table with 100 kids. You want to know what is the best prediction of how many will have a nap time at 1:30 p.m. So if you look at the table, it says 35 out of 100 kids have a nap time at 1:30. Okay. And now there's 2 ways we can look at this, and we're going to see how the math comes out exactly the same. So we said if you have a probability, in this case 35 over 100, we can expand that by however many trials we want, or in this case how many people we want, which is 1,000, and we can just multiply by that number. And then we just put this over 1. And this gives us 35 times 1,000 is literally 35,000. 100 times 1 is just 100. We take our excess zeros here. We can say cross these off. And 350 over 1. So we get 350 kids who would have their bedtime at that time, 1:30. Okay. The other alternative, which I saw some people doing, which is perfectly okay, is to think of this as, you know, just your regular old ratio. What does 35 over 100 mean? Well, the 35 represents their nap time, right? Nap time, and then the 100 is the total. I guess we could say nap time at 1:30, right? And we can make a proportion out of this. So 35 kids have a nap time 1:30 out of 100. And then we want to set that equal to how many kids is that out of 1,000, right? And then we'd cross multiply and divide. But now if you think about it, look at what we multiplied. 35 times 1,000, that's the same as what we did here, right? And then you would have taken that number, 35,000, and divided it by 100, which is what we did here. So either way you do this, either way you want to look at it, you're going to end up at the same answer, which is 350. So I'm not going to tell you which one to pick. Whichever one you like better, go with that. Okay? Alright, that was one. So another one exactly like that was number 4, which is probability of an egg being broken is 3 out of 25. How many is that out of 600? So again, you could either say 3 over 25 times 600. What does that equal? Or you could say if we have broken eggs compared to total eggs, and that ratio is 3 to 25, what is that out of 600? And either way you like better. Another thing we can look at, which we haven't talked about, hopefully some of you would come up with, is we can simplify some fractions. Neither of these can be simplified. But if we think about the math that we do, right? When we multiply, the order does not matter, right? If I said 2 times 3 times 4, that's the exact same thing as 4 times 3 times 2, correct? So what we can actually say, just hypothetically, is that the order of 3 and 600 doesn't matter. So this is the exact same problem as 600 on the left side, 3 over here, and we can even leave the denominators just the way they are, 25 and 1. And we get the same answer either way. This is still 1800 over 25. Okay. Why we do this is because now if we look at it, I can simplify this number, right? We can say both of these numbers, we can divide both of these by 25. Right, so let me bring it down here, 600 over 25. And if you didn't see 25, you could also say, well, they both end in 5 and 0. We can divide them both by 5. Actually, let's do that just for the sake of this being a lot of fun. So 600 divided by 5 is 120. 25 divided by 5 is 5. Okay? And we could say 120 over 5 times 3 over 1. Or we could keep going. I can divide this more. These both end in 0 or 5, which means I can divide them both by 5 evenly. And that'll give me 24 over 1. Okay? So what this really means is we can rewrite this as 24 over 1, which is the same number as 600 over 25, times 3 over 1. And boy, that certainly does make this multiplication a little bit simpler, because this is just 72 over 1, which is just 72. And that's broken eggs. Okay? So, the reason we point this out is because, not necessarily with numbers this big, but if it was just, say, I don't know, let's say 2/3 times 3/4. Alright? Most people can say, well, 2 times 3 is 6, and 3 times 4 is 12. And I know I could simplify that. 6/12 is 1/2. Right? But if we think about this, I can't simplify either of these fractions by themselves, but since the order doesn't matter, I can actually simplify diagonally. I can simplify just like this. So I can say, what do 3 and 3 have in common? Well, I can say, I can divide both those by 3. So this will become a 1, and, oops, the wrong color. This will become a 1, and 3 divided by 3 is still 1, right? And then 2 and 4 are both even, so I can divide both these by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. And now, it's a little messy, but what I have is 1 over 1 equals 1 over 2. Hold on. I didn't mean to say that. That's wrong. 1 over 1 times 1 over 2. Totally different. And then this multiplication is, this is baby stuff. 1 times 1 is 1. 1 times 2 is 2. And we have our answer. And again, it's just like before. You can simplify before you multiply, which is this one here. Or you can simplify after you multiply. Okay? But what makes this easier is that as soon as you multiply, your numbers tend to get bigger. And the bigger the numbers, the less obvious it can sometimes be that you can actually simplify it. So if you can simplify before you multiply, it's generally easier. Okay? That's just a aside, some extra information that might help you out. So really, the answer to this question was just 72. If you took nothing away from that, but you can still do this, you'll be okay. Okay? Alright, and our last one. This one probably shouldn't have been on this homework. This is like a different class of question, but that's okay because it's kind of a good question. So we have an independent event here. We want to spin, or no, it's not spin a number. It's not a cube, so we're rolling a number. You get 1 through 6, and then we have a spinner that's 2, 3, 4, 5. What's the probability of getting a sum of 9 or more? So what we can look at, let's make a couple of sample spaces here. Curly braces. On our cube, we have 1, 2, 3, 4, 5, 6. Close curly braces. And then on our spinner, we have 2, 3, 4, and 5. Alright. So what makes this more difficult is that it's not a real specific thing we're looking for. Like usually we'd say, what's the probability of getting a red 1 and then a blue 3, right? They give you something simple like that. So you say, oh, there's only 1 1 here, so that's 1/6, and there's only 1 3 down here, so that's 1/4, and we just multiply those together and get 1 over 24. Right? And that's simple. But this is a little more advanced because it's saying a sum of 9 or more. Right? So we have to think, what makes that true? Okay? So we think, how can we get a sum of 9 or more? So if I look at 1, if I pick a 1 as my first choice, can I add any of these blue numbers that'll give me a number that's 9 or more? And the answer is no. The biggest one is 1 plus 5, which is 6. That's not even close. Okay, so we go to 2. 2 plus any of these blue numbers. None of that equals 9. So we keep going. So we look at 3. 3 plus 5 is 8. That's still not enough. We're getting close. So now we get to 4. 4 plus 5 equals 9, which is a favorable outcome. So we can say one of our favorable outcomes is 4, that's red, and 5 is blue. We can actually, let's say this is from the cube, and this other numbers from the spinner. We're just going to make a list of everything that works. Okay, so that's it for 4. So we look at 5, and we think, what can I add to 5 that'll give me 9 or more? Well, 5 plus 4, that's 9. And then 5 plus 5, that's 10. Right, so that's good. And then we go to 6. So I know 6 and 5 is going to work, 6 and 4, but we also have this 6 and 3. So, okay. So hopefully that makes a little bit of sense. We're just picking all the outcomes that give me a number that's 9 or more. This is 9, 9, 10, 9, 10, and 11. So we count these up. We say, how many favorable outcomes are there? And there are 6 of them. 1, 2, 3, 4, 5, 6. Then it just becomes a question, how many possible outcomes are there? Okay. So the way we can think about this, a couple different ways you can think about it, is, first of all, what we did with our dice, we said that when we multiply this bottom number generally, if we don't simplify it first, gives us our number of outcomes. We can say 24. We can look at it, we could make a, hold on, I'm just going to do part of this. I don't want to write them all down. I could make a tree diagram. I could take, if I pick a 1, what are my options on my spinner? If I pick a 1, we get 2, 3, 4, and 5, right? And then we can add these up to get our final totals. And we see how none of those work, so we didn't count any of them, but that's 4 outcomes. And then each other number on this on the cube will have the same number of second parts of the tree here. It's always going to be 2, 3, 4, 5. So for each number on the cube, there are 4 outcomes based off of what you get on the spinner. So what that really works out to is 6 times, go crazy with my colors here, 6 times 4, which still gives me 24. So basically what we're saying, to find the total number of outcomes in any compound event, not any, I don't want to specify that, any ones you're going to see until you get more information than what you have now. The total number of outcomes will be the number of different outcomes from one event times the number of different events or number of different outcomes from the second event. So in this case, 6 times 4. Okay. You could also do this if you really wanted to and weren't afraid of making a big awful mess. Whoops, no, you stay there. No, I said stay there. Okay. We could also draw some arrows here. Let's go purple. We could say we get 1 and 2 as an outcome, 1 and 3, 1 and 4, 1 and 5. That's 4 outcomes. Let's change our colors up and go 2 and 2, 2 and 3, 2 and 4, 2 and 5, all outcomes. Yellow. We say 3 and 2, 3 and 3, 3 and 4, 3 and 5, and so on. And again, we still see it's 4 for each of these 6 numbers. Still 4 times 6, still 24. So that's still 24 outcomes. So then the very last thing we'd have to do with this is simplify it. This is 1 out of 4. So 25% of the time, if you're given these choices, you would get a sum of 9 or more. Alright, hopefully that wasn't too confusing. But that's it. So good luck with the rest. Okay, good night.